Today, let's talk about vectors. Vectors are an integral part of physics. Without that, most of physics is not possible to learn. For a class 11 or class 12 student, knowing vectors is very important. Let us start with the definition of a scalar. What is a scalar? What is a scalar quantity? Basically, a scalar refers to a number. Here, a scalar quantity is a physical quantity with only magnitude and no direction. For example, mass. Mass is a scalar quantity. Why? Whenever you tell a body has a mass, you are telling it has 1 kg of mass, it has 2 kg of mass. Are we saying that it has 1 kg of mass in north direction? Are we saying it has 2 kg of mass in southwest? No. So we are not associating a direction with mass, we are just giving it a number, that's all. So similarly for temperature as well, we are not telling that in that direction it is 20 degrees Celsius, in this direction it is 40 degrees Celsius. No, we are not saying that. We are just giving a number for a particular place that it has a temperature of 20 degrees Celsius, that's all. So temperature, mass, speed, all these quantities are scalar quantities. Without any direction, it has only a magnitude, that's it. Now let us talk about the definition of a vector. Okay, what are vectors? A quantity, a physical quantity that has both direction as well as magnitude. So those kind of quantities are called as vector. Now we may get a question that whatever quantity that has direction and magnitude, will that become a vector? No, the answer is no, because for example current has a magnitude, electric current has a magnitude and as well as a direction, but that's not a vector because it doesn't obey the rules of a vector, because vector has some certain rules. For example, if you want to add 5 plus 2, the answer is 7, you can just algebraically add the two numbers. So that is just a scalar addition, okay, number addition. But if you want to add two vectors, there are certain rules for adding those two vectors that we will see in this video. If the particular physical quantity does not satisfy those rules, then we cannot say that physical quantity is a vector. So it must obey the rules of vector addition as well. Examples are force, velocity, those kind of things. Okay, how force becomes a vector? Does it have direction? Yes, because whenever you tell that you are pushing a box or something, you are telling I am pushing it very hard, but the box is not moving. But you are also telling I am pushing the box in this direction, right? So if you want to push a box with a force, you have to give a certain amount of force. That amount represents the magnitude, and the direction in which you are pushing it is the direction of the force. So if you push an object, you have to give an amount of force in a particular direction. So therefore the force has a direction as well as magnitude, so it becomes a vector. Okay, now let us talk about how to represent a vector. So we have seen what are vectors and we have seen examples of vectors, but how to represent a vector, how to write a vector. First of all, to write a vector, in most of the books we use bold letters. Books uses bold letters, but when we are writing we can't use bold letters, right? So generally people, when they write vectors, they will write a letter and then they'll put an arrow mark on top of that. This particular representation represents a vector. So if we are writing a vector in this format, how to represent that vector? To represent a vector, we have to draw an arrow mark. Why to draw an arrow mark? Because it's a convenient way of representing a vector, because it has a length as well as a direction, right? And an arrow mark points to a direction. So the length of the arrow mark can be used to represent the magnitude of the vector, and the direction of the arrow mark can be used to represent the direction of the vector. So every vector has two parts, that is a tail and a head. So from tail to head, the length represents the magnitude and the direction of the arrow mark represents the direction of the vector. Now let us talk about the equality of vectors. Now, when are two vectors equal? Two vectors can be equal if they have equal magnitude and the same direction. For example, let us take two vectors. If you see the arrow marks here, they both have the same length and they have the same direction. So therefore these two vectors are equal. So if this vector is represented by A and if this is represented by B, then A vector equals to B vector. That's it. even though the magnitudes are equal and the directions are not same, then the two vectors are not equal. For example, if I have a vector like this and if I have another vector like this, same magnitude but different directions, so they are not equal. If you are having any doubts regarding any concept, just leave it in the comments and I'll try to reply to everything. And if you haven't done yet, click the subscribe button for more such content.